This video introduces the COVERT tool, the compositional analysis of Android applications. In recent years, we are witnessing a significant growth in the number of mobile app ecosystems. Despite of their success, this growth has led to a new security threats. According to the Semantics 2014 report, the face of cybercrime is changing toward mobile users' applications. To show the importance of compositional analysis, which is the distinguished capability of COVERT, in compared to other tools, let's look at an example. Suppose that we have installed two applications in our Android mobile device. First one is a weather application that shows the weather condition either manually by searching the city name or automatically by using GPS-based locations. The other application is a simple messenger app that sends text message to a phone number using SMS services. However, both apps are vulnerable. In the first application, instead of using an explicit intent, an implicit intent is used to send GPS location from one component to another one in the same application. This is a common practice among Android developers, but also an anti-pattern that may lead to intent hijack. In the second application, a public interface is defined for a service component that sends text messages, but that component does not check the permission of message sent. So other applications, even without the SMS permission, are able to send text messages by exploiting this vulnerability. As a result, a malicious application which is installed in the same device can exploit these two vulnerabilities and send the device location to a desirable phone number via text messages, without the need for any permission. Let's see how COVERT detects these kind of inter-app vulnerabilities. COVERT tool is implemented in two layers, the backend that performs analysis on the applications to find potential vulnerabilities, and the frontend that provides an interactive environment intended for use by the end users. Let's start by the desktop application. In the desktop application, you can either run the backend engine on a bundle of selected applications or show the result of previously analyzed applications. Now, we can select the applications we want to analyze. Here, I want to select the applications of our case study, which I just introduced, the weather application and the messenger application. Now, the COVERT back engine is analyzing the selected applications. Okay, the analysis results are ready now. On the top right panel of the tool, detected vulnerabilities are categorized by their type. For example, here we have two classes of vulnerabilities: intent hijack, intent spoofing, and inter-app information leakage. If you select each class, the list of detected vulnerabilities belonging to that class are shown in a hierarchical structure in the bottom panel. In the right panels, we can see a possible exploit scenario of the selected vulnerabilities in both text and graphical notation. If we expand each vulnerability, we can see the elements involved in that vulnerability. For example, here we can see two apps are involved in a potential inter-application data leakage. Then we can go further and expand each app. For example, in the weather application, the main activity is the vulnerable component. In particular, the sensitive source, which is the location information, is retrieved in the onClick method of this component. Moreover, if you're a security analyst or an app developer and you want to inspect and backtrack the vulnerability in the source code of the application, you can see the decompiled Java code in the source code tab. The highlighted areas in the source code are related to the vulnerabilities. For example, here you can find the source of leak data, which are the location retrieval APIs. Sometimes the source code is obfuscated and the decompiled version is not readable. In that case, if the source code is available, it can be attached to the results. Here we can see the other elements of the vulnerability, which is the send SMS service of the messenger application that sends text message to a phone number. As an alternative client support, the end users can use the combination of mobile and web-based application to analyze the installed app in their own mobile devices without the need for directly providing the app bundles to the backend engine. In the COVERT's mobile app, we can select the install applications to be analyzed and then choose a username and call the app analyzer. The mobile device IMEI will be used as a password to access the generated reports. In the COVERT web application, we can see the analysis result. First, we enter the selected username and password, and then we can see the result, which is similar to the reports provided by the desktop client tool. Thank you for watching.